It was good today. Chemical kinetics. Just a circulatory earlier. So what does kinetics answer? It answers like how fast a reaction will occur. It answers like how a reaction occur. Like I was saying like how fast it'll occur, like rate and stuff like that. So how do you express reaction rate? So it'll be concentration per second. So changing concentration per second, and then the reactants will have negative signs because their concentration is decreasing. Now, if there's a coefficient with the reactant or product, you're going to put that in the denominator because that said thing will decrease or increase by a factor of whatever that coefficient is. So yeah, what does the rate law relate? It relates the concentration of reactants to the rate of the reaction. What is not included in the rate law? You're not going to have any products or intermediates in the rate law. What is the only way that you can determine rate constant order? You have to use experiments, so you have to have trials in order to be able to find out what the order is in the constant. What is the overall reaction order going to be? It's just going to be adding up the orders of each reactant, and then you're going to get, so if you have like A order 2 with B order 3, then the overall order will be like 5, or like 1 and 1, it'll be 2. So how does temperature, EA, and reactant affect rate constant and rate of reaction? So reactants will not actually affect the rate constant, the concentration. However, they will increase the rate of reaction, I believe. It'll increase the rate law, and then wait, I don't even see the graphs. Concentration affects rate directly, so directly proportional, and then temperature and activation energy will affect the rate constant, and that rate constant will then affect the rate proportionally. Concentration will not affect rate constant, but it'll affect the rate directly. What order is radioactive decay? That's first order. What does graph of zero order, first order, and second order look like? Zero order will be a negative, no, it'll be a positive sloping line. Or no, not. It would be a negatively sloped linear line. First order will be, I'm not actually sure, put a star. First order, zero order will be a linear decrease. First order will be exponential decay. Second order will be a reciprocal linear plot. Interesting. What is the rate determining step? How is it related to EA? So rate determining step is the slowest step, and that's what the overall reaction will, like that's what the rate of the overall reaction will depend on. EA, the rate determining step or the slow step will be the one with the highest activation energy. It'll take the longest to proceed, so it's the slow step. What is intermediate and catalyst? So intermediates, they are consumed, or they're like, intermediates are like produced as a product, and then they're like included in the reactants in the next step. Like if you look at the elementary steps, like the mechanism of a reaction, say equation 1, the elementary equation 1 will produce chlorine. Then if the second reaction also uses chlorine, then it'll cancel out, and that's going to be an intermediate. A catalyst will be used, like it'll show up in the products and the reactants, because it's used, but it's not like consumed in the reaction. What are 3 conditions of chemical reactions? So the 3 conditions of chemical reactions. So first, they have to be, they have to have enough energy to overcome EA. So like these molecules have to be like, having energy. Next, they have to orient themselves properly, the proper shape, like they have to hit each other on the right way. And the last one is, I forgot, effective collisions. What does that mean? So it says proper orientation, sufficient energy, and effective collisions. Oh, that doesn't count as one though. I'm not sure. So what does the rate of reaction depend on these three? Oh, I want to know that. Let me try finding the video. Bro, why can't the AI just answer properly? Bro, I did a mini test on this. I got 100% in chemistry somehow. Bio, I didn't do as good because I didn't know everything, but the stuff I did know, I got them right. PAT, I honestly did quite well, like better than I thought I was. I only got 2 questions wrong out of all of them, and it was only the angle ranking, and I can work on that. I thought angle ranking was my best, but I guess maybe not. And then, yeah, reading comp, I just got molested, bro. That was my worst by so far, bro. But wait, what was I saying now? What was I talking about? Oh, I'm trying to find the video content, chemical kinetics. Collision theory. Molecules must collide. Molecules must have the proper orientation. Oh, what the heck? Molecules must collide. They must have proper orientation. Okay, so what's going to be, I think it's going to be the colliding. Like, it depends on how fast they collide. That's the only thing that makes sense. Yeah. Okay, so the 3 things are that they must collide. They must have sufficient energy, like EA must be overcome, and they have to have proper orientation. So now, the rate of the reaction will depend on how much these collisions occur. So that's what depends on it. What is the Arrhenius equation? Well, I'm trying not to look at it. My eyes are closed. K is equal to A, which is the frequency of collision, I believe, multiplied by E, which is natural log, to the power of negative negative EA over RT. Yeah. What is A? Frequency factor, frequency of collisions, probably. A relationship between EA and temperature with rate. So as you increase activation energy. Wait, hold on. As EA decreases, you'll have a faster reaction. That makes sense, but I don't really get it from the Arrhenius equation standpoint. Like, if you increase, there's going to be if you increase the reaction rate, you're going to have a higher power. So it'll be E to the power of something, but E is 2 point something, so why just keep on increasing? But anyways, temperature, as you increase temperature, you will increase the rate constant. Bro, wait, how does E? Oh no, it says EA decreases, then rate constant increases. Wait, what? Okay, I guess it's opposite because it's in the power of. That's interesting. Okay, what's the relationship between EA and temperature with rate? That's what it said. Temperature does not affect the activation energy. The only thing that changes activation energy is the catalyst, because it provides a different reaction pathway. So that's all for now, for today, for chemical kinetics. Goodbye.